Hello, this is ABC and welcome to Data Engineering and Infrastructure Community. Going to deploy Apache Spark on Kubernetes. I will be using local cluster ecosystem. So I will be using Kind. Kind is actually a Docker container, and inside Docker containers, entire Kubernetes ecosystem is built on. It's pretty fast to deploy and use. So there is not a very huge learning curve to understand Kind. There are other local clusters as well, like Minikube, K3s, MicroKs. You can pick any of them, but for this session, we will stick to Kind. In this particular part, we will focus on deploying Spark on Kind, using as a Spark shell, then using as a Spark deployment by customizing workers and master, and then using a Helm, which is known as Spark on Kubernetes operator. So using that operator to deploy Spark. In this particular session, we won't be focusing on explaining Kubernetes, and we won't be focus on optimizing Spark, but we will rather focus on how to deploy them quickly so that if you want to really deploy Spark on Kubernetes in a fastest way, how can you do that? Since it is a local deployment mode, I can ensure you it doesn't change much for the production system, except optimization security. That is a very different landscape. But if you have a Kubernetes ecosystem and you understand how it works, and in a local cluster, deploying them in production is goes around the similar specs, but it has more broader thing to consider, like data security, privacy, and access. All those things are different in cloud services.
Okay, so we are in Kind. Kind can be installed in Mac by Brew or in Windows by Choco, and it supports almost many binaries as well if you want to install in that way. The installation is simple. You just do the Brew, and after that, I have already done the installation, so let's go and check what is there. So we can say Kind get clusters. So it says I don't have any clusters. So that is good because that is what we wanted, because technically we don't have any cluster as of now. We can directly go from the particular section of creating a cluster, and it just says create a cluster with any name here. That's what we will do. So we are going to set up Spark, so we can choose any other name. So we can say Kind create cluster, don't name something dosa. Yeah, why not? Breakfast time. So we started with dosa and saying our first cluster name will be dosa. Let's see what happens when the first cluster name is getting created. So it takes a bit of time, not too much actually. And once it does, you can just check all the clusters you have. For now, we started with only one cluster, so we will see that cluster is there or not, and then we can just set in this way the context. So in Kubernetes, you can have many clusters, and you can switch between those clusters by using this particular command context. So now we are here, and we can just do the command Kind get clusters, and it tell us, yeah, I have those are with me. So I can say Kind, oh sorry, class. Oh, let's copy this entire thing, and you see the context is always prefixed with Kind. So whatever the name you will give, that will prefix with Kind when it comes to clusters. So name is different, context is different. So it says your cluster is running in blah 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 blah, and if you want to know more about it, go and do the cluster demo. Okay, fine, I don't want to do as of now anything. I just want to see what happens. So I created something, what is happening actually. So behind the scene, if you do Docker container, you will see this. Yes. So it actually runs something in your Docker. In this context node, in this particular container, your entire Kubernetes is running. So that's how it works. And you know this is the name. So this is actually a node name. So what does it mean? Node name is actually the main node inside. Control plane is actually the master and worker in this particular case of Kind, and you can use any. You can even create multi-node cluster as well in Kind. So for now, I want to get inside it. So I will say docker exec, and I will say, okay, show me what is there inside control plane. So it is, remember it is container D, so it is CRICTL, and you can check all the images inside it. So now we have set up kind. So let's go ahead and install a cluster inside kind. If you see, the installation is pretty simple. You just say kind create cluster with a name if you want to give a name, or if you don't want to give a name, it will set up any default name. So it says the default cluster name, context name is kind. So no, I don't want the same name. So I will say kind create, oops, okay, and I will name it Apple. So it will create a cluster name Apple, which will have technically entire Kubernetes stack running, like API server, kubelet, proxy, and it is etcd and many more things. So those are the things you can now verify once the cluster is getting created, and this is the way we set the cluster. So if you have multiple cluster running, you can just set the switch between different cluster based on that. Now once if it is done, we can go and check. So we can check what are the kind clusters. Okay, so it is saying Apple is available. There is another very important thing in kind which you should remember is do not use latest tag. So if you read here, the entire concept is provided, but technically if you give latest, it actually try to download things. So the basic point is, even if you provide tag, the recommendation is always set the image pool policy to either if not present or image pool policy to never. I actually use never for everything because I manually load the images inside kind, and then I put my policies always never. It just solves the problem. Even I don't use if not present, just to be sure. Okay, so we have installed kind, and now there is a tool called Lens. I use Lens for Kubernetes management to see what is pod running and see the entire ecosystem of Kubernetes. You can use another tool, but for now I am using Lens. I have installed Lens, and it's a UI based tool. So I can open Lens and I can check for something called kind Apple. This is what I created now. We can go inside it and have a look. So clusters, there is nothing, matrix available is not there, but in the node I can see ABC Apple control panel plane is ready. If you get inside it, you see I have assigned 8 cores, 16 gigs of memory, ephemeral storage. This is all Docker configuration which I said. Then there should not be any pod, there should not be any deployment, but it is out clean servers, and that's how you can actually look when you deploy things inside Lens, that what is happening, what kind of pods are getting created. For our this small tutorial, we will go with Lens and we will see how it works, and when you deploy application, how can you view up the things inside Lens. Usually in our case we don't even need Lens, but it is just for convenience. If you don't want to do it from console, you can do it from Lens. Okay, so after installing the setting up the kind cluster, the next we need to do is build a Spark image. You can reuse any particular Spark image, or you can directly go to this particular Spark doc and you can actually see how to build image of Spark. For our case, I have already pre-built a Spark 320 pre-built image, and we can check it here in our command. Okay, so we can see in our Docker image, I named the image of the Spark kind, and if you see, this is the Spark. This is actually nothing but a Spark Docker image with 320 as a version. We'll say kind load Docker image, and you can just say Spark kind 320, and our name is Apple. That's good name. So now it is trying to load that image inside our kind. And once that image is loaded, then we are in the particular situation that we can already start working on it. We can already deploy application on top of that image, and client can directly access it. Okay, so now it got loaded. Let's see. So its Spark kind is here. You can see that came up, and it means the Spark image is ready and we can now use it. So now I'm going to show how to create Kubernetes deployments for Spark Shell kind of access. And for that, I have inherited this script from test-driven.io. I will share that link from how it is inspired, and I have modified them with whatever the way I wanted it required. But it is mostly inherited from test-driven.io. So now here we will create a deployment, as you can see, and in that deployment I just name it Spark Master, and there are not many things to care about. You just need to have an image name, what you just use, spark country.o, and command is related to a Spark service endpoints, and what are the ports you want to open. So we know in the Spark clusters we need 7077 and 8080. I just added them, and CPU you can provide here anything as per your particular machine. Then since we created a deployment, now I'm going to create the service to expose, and you can see WebUI is on 8080 and the Spark cluster is going to run on 7077, and the selector component is Spark Master. That's for the deployment side of it. And for the worker, things are going to be more or less same. Only thing is I'm going to add replicas. I have added 3 replicas. It means I should have 3 worker and 1 master. And the container ports are 8081 for this case. Now I've created them. I need to run them in order. So like master deployment, and then a master deployment, then master service, and finally worker deployment. For that, and this script is doing nothing but just deploying the master first, then the service first. Just wait a few times, and then it finally runs the worker. To see the next step on the file, we can actually go here, and in the it is lens, and you can see I have a master got launched, and I have 3 workers. So as soon as we go to the lens, if you remember last time, we just go and click to the range, and everything is happening in the default namespace. It is running here, and let's do port forward for particular this and see what happens. So you can do the port forward from normal from your shell as well, and we just did it from it, like kubectl port forward is not a very big command, but as you see, my master is up on Spark Master 7077 and nothing is running. 3 workers are up. So you already deploy Spark in a runnable mode, I think in just 3 files: deployment, a master, worker deployment, and a service file. Put a Spark shell on this, right? So since it is now up, one thing I can see is I can check my git pods and see here the same thing. It is running on the control plane, and I can check what is my IP for the master. So if you see, my IP's master is this thing. It is required to provide the driver bind address and the driver host address, which by the way you can give hostname minus I as well. Okay, so we will launch a PySpark shell on the Spark master, which is running already. So this one, and here for that we just need the master name, pod name. This is the master pod name, and for that what we can do is we can say kubectl exit, and this is our master name, this is our master name, and then I will say IT on that, and you can say I want PySpark, and so I can do it full. I can with PySpark. Now we will try to run a PySpark shell on particular Spark, and for that we need our master pod name and the IP addresses to set the bind address and driver host. So the command is simple. It is like kubectl exec, and I need the master now, and for that I will say and then I will go ahead with PySpark. The conf will be just Spark driver. In some cases Bind address doesn't take as an IP. It recommends to use hostname minus I, but for if I say my name is this, it should take it. Yeah, let's took it. So now it is running. It is trying to run. So okay, we can see a Spark shell is up. That's good. So let's do something out of it. So I need some string. Wow, why go further? Copy this and copy this. So I just see the count. Count is all 1111. GIB is 2. That's good. That's it. It ran. And now I can stop it. So that it is that simple to run Spark shell in Kubernetes. And here, if you see anything, there is nothing much in the pod section changes. It is just like it is running few of the things, and you can actually go to the master to see if there is a logs or not. And there is two approaches which I'm going to show. First approach will be using our own based on the Spark doc, and another approach is there is an operator known as Spark on Kubernetes operator. So these are two separate entities, and we can consider them, maybe one is staging and one is production. And specifically in Kubernetes, usually we have a different clusters or control plane for this kind of ecosystem or a tenant. So we can create two separate kin clusters. Staging is done, and then we can go to the production. Let's see. So it is going to create the production cluster, and then we can go to the cleanse, and we can see that staging is here. Use contest kind of staging. Okay, so I now move to the staging cluster, and now I can go and check config. What is my current context? It should show me staging. So okay, I'm inside staging. Now here in our code, if you see, I have moved this particular file, and I am going to create two executors, and that's it for now. Usually now it will fail. We will see why it will fail later, but let's see. For us it seems like everything is fine. Why will it fail? So I'm going to launch this job inside the default namespace and then apply. Good, it got created, and now we can go here and we can check. Okay, job has created. I'm not seeing any pod. Okay, oh okay, something is happening as we expected, and it says it is forbidden because it is trying to look for a service name as Spark service account, which is not found. And yes, you need a service account where your driver, it means the Spark master, has power to create pods in different executor node for the executor nodes. So it needs an access in Kubernetes so that it can create some entities or the lowest element in the container, for example. And that is the beauty of Kubernetes, where you can control all these things, like exactly which service can create a particular job and which can't. So I didn't provided that, and I need to create it. So I actually provided the name here, service account name, but I actually didn't created anything. So for that I have a Spark RBAC file where I just define the service account to be created inside the default namespace. Then I created a cluster role, and the cluster role is edit, and that's it. I just link that to the subject of the Spark service name. It is failing, so we have created the Spark RBAC file. So let's go and create this, run this file again. Okay, so it has created service accounts with the Spark name, and it has created a cluster rule, cluster binding rule. Just for information, you don't need cluster role binding every time. You can actually create a role, and which can give you all the entity, and you can see in the cluster role I have provided edit with the name as Spark role, but you can actually create a role and role binding as well. For Spark you don't need actually cluster role, but just for simplicity I just created a cluster role. And then I have provided the account name to this executor, and in this particular fashion as well in the container level of the Spark. Okay, now I just need to do is I need to apply the job. The job name is test job. Okay, and I applied. Let's go to here, And we can see with the job, I already got something called driver. It is an older job which I created previously, so you can ignore on that part. But with this new driver, as you can see, it created two pods here, and it is now running. It succeeded. We can go to the log and we can see the pi value has come. Okay, that's good. Okay, let's try to launch for the job. So I just clean this job as of now. Okay, and I try to see what are the other jobs I have. Nothing is there, so it should be clean. And I have some pods, so I have del pods. I can go and clean all of them from here. It should be removed. So my pod is clean, and I can go here and can say, okay, create 5 instances. Everything else will remain same. I don't need this much, so I will just say my, okay. And oh, this is the memory, so it will take this kind of thing. Okay, so I will just provide for 1G only, no changes, and just see I can apply it or not. Let me see like what it says failed or not. So now it should create 5 instances technically, and in local cluster, as you see, it instantly does everything. So you need not wait for a production cluster. That's why you should have set up a local cluster and running this. So it now created 5 nodes. So everything is smooth in Kubernetes. It just create all those pods instantly, and they all are communicating with the driver. Once the driver is ready, it just finishes it and it just gives you the log. Again the same, and this jobs is just executed, which finish all the cluster mode interfaces. And then you just need to do is delete the job if you don't want to have it, or you can keep it. It depends. Thank you very much. In this video, we are going to deploy Spark on using Spark on Kubernetes operator. This is a pretty popular and widely used Kubernetes operator for Spark because it manages the entire life cycle of Apache Spark. Okay, now we will go with the installation of Spark operator. It is a Helm-based operator, but it comes with its own values file, and I have my own values file for here. So this is the values file where I didn't made many changes, but as you remember, I now have another Docker image, which is Spark operator, which comes with again bundle with the GCR registry, and I have downloaded it. I will have to upload this in our CRICTL images, and then it has again this service account of Spark, which previous application we saw it needed, and here you can control the threads. So one of the thing happened in our production system is we were trying to run Apache Spark application like 10-15 of them, and suddenly we were seeing things were going on queue, but it was taking quite a lot of time. We were not at all getting response that what is happening, why the job was not getting submitted. Then we will realize that these threads are actually, if you are going to run many jobs, you need to play with all these things like how the controller threads work, and has more further granular ways of working on this particular segment. We have metrics, but we don't have pod monitor setup. We didn't do any of those things for now, and I didn't change anything beyond it. I just look for now only this particular images. So to work with Spark Kubernetes operator, I need to load all these 3 images. Scala I used a new cluster name as I need to do the helm install of this particular values file. Okay, so for that I just need to do I just named it sparkrel, and I use the values of YAML file, and I'm saying it to install on particularly on the default namespace. So I install it, deploy. What happens is in the deployment you can go here and you can see it is progressing. It is trying to launch pods. We can see it has created an operator pod which actually reads everything in the diagram. We saw how it works, and it has 4 layers. In that particular operator pod, it means here things should be running. So if I go here, it's just created routines controller, Spark scheduler application. Okay, so things are now ready. So this operator is ready. Now what I can do is I can go and try to run my Spark PyJob, which creates 2 instances, 1 core I can provide a code limit, no, not required, and just run them. So let me run and see what happens. So I'm saying go and run to the Spark Pi, and I did. Meanwhile, I can see what it submitted Spark application. It failed. It failed. Why it failed? What we can check it here is we can say describe application on the Spark, and we can go and we can say what happened. It says services record account may be revoked. Spot Pi driver is forbidden. Good. So I think we all have some idea why it happened. So I will remind you that I didn't run the Spark airbag file. Here it is. So I will do a Spark apply, go and run the RBAC file first. Yeah, so I've now run the RBAC file. Now I say, okay, now run the Pi file. I run the Pi file and I say, okay, get me the Spark application. It submitted the job. It submitted the job. The driver is created. As we know with driver, I should be expecting here 2 pods. Yeah, it happened. 2 executives are now running. And it will finish, yes, instantly, and I should get the Pi file here. Good, that one. Now I will run the Spark Pi file. Okay, so I will run in the same operator my Spark Python file. It is Spark Pi file. Okay, Spark Pi file on the same thing, and I submitted it. I want to check the application. It is now trying to schedule. It is now running. I can go. I can see Spark Pi driver is now running. With that Spark Pi driver, it should again expect me to execute this here. Nothing very different and extraordinary. So now the same thing happened. The driver is completed. I can go and check the logs for the Pi drivers. It should be same, roughly the same. And here we can go and find this. Here we can see what happens. It completed all the job in the log, in the operator log of the Spark rel operator. You can do the same thing here. You can say Spark describe Spark application, and if you do this, you will get all the events, what happened when it ran, how it ran, how it is. So all the events and stages are updated here in this particular format, and you can do the same thing with Pi as well. What was the name? So you just need to do Pi Spark Pi. So yeah, same thing. You can see the log from here as well. So as you can see with operator, you again just need to install the Helm, which eventually creates a pod. You need a service account, and then you run any kind of job directly and deploy on the cluster mode. And all the logs are ready. Eventually this pod will dead. But for the pod and log scenario, I won't recommend you store the log here, but technically you can store it with any ELK module or Fluentd in Kubernetes, which will read all the logs and store in some persistent disk like in S3 or somewhere, or in Elasticsearch to search. But the logs are still here. If you still want to find, you can find the logs here, and you can, with this operator, you can run hundreds of jobs, and everything will be managed under the same Spark application module. So these are the ways you can actually run Spark jobs with shell, with the Spark documentation requirement, and based on that requirement, or in Spark Kubernetes operator. So all the codes what you are seeing here, it will be submitted, and all the link you can find in GitHub. Link to the source code will be available in GitHub and data engineering Telegram channel as well, and in this video comment section or description section you will find all GitHub link. You can directly download the link and already start working on it. Thank you.